All right, guys, so what we're going to do today is we're going to finish up the note sheets for 3-3 and then do 3-6. I'm putting those two together mainly because, well, we do need to finish 3-3.
Miss Kendall, please call the office. Miss Kendall, please call the office.
But also because 3-6 is actually not that bad. It's actually kind of an easy chapter with inequality. So kind of putting the two together. Now, we won't have an assignment. Well, your assignment for tomorrow is just doing the homework. There's nothing really going on tomorrow. We'll do 3-4 Wednesday, 3-5 Thursday, and then I'll let you work on the review sheet Friday, which means we're taking the test after the break. There's just not enough time to squeeze it all in, and I'm not going to try to force it. So we're taking the Chapter 3 test after spring break. I'll give y'all till Sunday of spring break. Give you a little bit extra time. But I wouldn't wait till the last minute to do it. Just go on and get it done. Yes. So what we want to do with these here is we want to use the remainder theorem to determine if the given number C is a zero of the polynomial function. And all that means is that if we use synthetic division with these here, we get a remainder of 0. Because if the remainder is 0, then they are a zero of the polynomial function. They are a solution. So when we start with 4, or A, we put 4 inside the cubbyhole, because whatever it's equal to is one of our solutions. Zeros, we can plug it in. Now we take the coefficients of the polynomial going across the top. So we have 2 for x cubed, negative 4 for x squared, negative 13 for x, and negative 9. And then we do our normal steps. Our first step is to do 4 times 2, and 4 times 2 is going to be 8. Then we add straight down. Negative 4 plus 8 is going to be positive 4. 4 times 4 is 16. Negative 13 plus 16 is positive 3. 4 times 3 is 12. And negative 9 plus 12 is positive 3. So that tells us that we do have a remainder of 3, which means that this is not a zero, it's not a solution. The only way we can get a solution, or it to be a solution, is if the remainder is 0. So this is no, it's not a solution, it is not a factor, because it would be a factor, well, here, because we had subtracted back over, C minus 4 would be considered a factor if the remainder is 0. If it's not 0, it's not a factor, it's not a solution, it is not a 0. We can do the same thing with the square root of 3. So we would put the square root of 3 inside our cubbyhole and put our coefficients of the polynomial across the top. Since there's not a number in front of x to the third, it's going to be 1. Number in front of x squared is going to be 1. Number in front of x is negative 3. And then our last one is negative 3. Again, the first thing we do is bring down our first number, so we bring down the 1. Now we do the square root of 3 times 1, which just gives us the square root of 3. Then we add straight down. 1 plus the square root of 3 is going to be, well, 1 plus the square root of 3. Now, unlike the last one where we're multiplying by a number, it might be helpful to do some of the multiplication for this one off to the side, because seeing what the square root of 3 times 1 plus the square root of 3 might not be as easy to look at. Now, we can multiply this here, distribute out. 1 square root of 3 times 1 is just the square root of 3. Square root of 3 times the square root of 3 is going to be plus 3. So we can say 3 plus the square root of 3, or square root of 3 plus 3. We can write it either way. Now, the yellow calculator, we could say, second square root of 3, parentheses, to get outside the square root. Parentheses 1 plus second square root 3. It'll tell us it's square root of 3 plus 3. The 30xs can do these in there. Now when we add straight down, well, the negative 3 plus 3 will combine their like terms, which will simplify out to 0, leaving us with just the square root of 3. Now we need to do square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is 3. Negative 3 plus 3 is 0. So the first one was no. Second one is going to be yes, it is a 0 because our remainder is 0. Now that is kind of nice to know if they told us that, because it means that c minus the square root of 3 is a factor of this. It is a solution. But it also means that c plus the square root of 3 is also a factor. Because according to the complex, or kind of the rational zeros, or our irrational zeros conjugate, if a plus the square root of 3 is a solution, then a minus the square root of 3 is a solution. If we have one square root, we have to have its conjugate. If we have one, we have to have the other. Irrationals always come in pairs, the positive and negative of that rational. Irrational. So we have that. Any questions on this so far? Now the last one we have is this here, and I'm going to erase this so I have a little more room, is this here, 1 plus 2i. And again, we can do this the exact same way we've done numbers, it just looks a little bit different. Now we would have 1 for x cubed. Now because we don't have an x squared term, we'll fill it in with a 0. 1 for x and then 10 for our constant term. Now in some of these we might need a little more space because again, we do have 1 plus 2i, so there's going to be a little more added in, but we can still do this here. Now our first step is going to be 1 plus 2i times 1, which is just going to be 1 plus 2i. That's not too bad. We add 0 to it, and we still get 1 plus 2i. So the first two on this are actually kind of nice, because 1 plus 2i times 1 is just 1 plus 2i. We add 0 to it, and we still have 1 plus 2i. Now we have to do 1 plus 2i times 1 plus 2i. We have to multiply those two together. So it might be helpful to do this off to the side, because we'll have to distribute. 1 times 1 is 1. 1 times 2i is going to be plus 2i. 2i times 1 is going to be plus 2i. And 2i times 2i is going to be plus 4i squared. But we know I squared is the same as negative 1, which is really just going to change it from positive 4 to negative 4. Just coming from the fact that I squared is negative 1. Now we can combine like terms. 1 minus 4 is going to be negative 3 plus, bless you. Now, the graphing calculator is somewhat nice with these here, because I could say 1 plus 2i times 1 plus 2i, negative 3 plus 4i, which is exactly what we got with multiplying out. So the graphing calculator can multiply these together for us just to make sure we do get the correct terms. Now we're going to add 1 to it. Well, 1 plus negative 3 is negative 2 plus 4i. Now again, we've got to multiply 1 plus 2i by negative 2 plus 4i. Distribute 1 times negative 2 is going to be negative 2. 1 times 4i is going to be plus 4i. 2i times negative 2 is going to be negative 4i. 2i times 4i is going to be plus 8i squared. But we know I squared is still negative 1. So it's really just changing it from positive 8 to negative 8. Combine like terms. Negative 2 minus 8 is negative 10. And 4i minus 4i is 0. And 10 minus 10 is 0. So can we say 1 plus 2i is a 0 for this here? Yes. Which means that c minus 1 minus 2i is a factor. And really the way that we get that is just moving everything back over with c. So c equals 1 plus 2i. We would subtract the 1, subtract the 2i, telling us c minus 1 minus 2i is a factor. Does this make sense? Now the complex conjugate theorem states that if 1 plus 2i is a solution, 1 minus 2i has to be a solution as well. If we have one, we have to have the other. They have to come in pairs. And this isn't a part of this problem, but I'm just showing that this does work. Because if we did it with 1 minus 2i, 1 minus 2i times 1 would be 1 minus 2i. And this here, if we add these together, well, 1 plus 1 would give us 2. 2i minus 2i is 0. So we just have 2. Now I have to do 1 minus 2i times 2. Well, 1 times 2 is 2. Negative 2i times 2 is negative 4i. Negative 2 plus 2 is 0. 4i minus 4i is 0. Yes?
So, since that's a lot easier, if we think it'd be easier, can we just do the negative version?
Well,
Opposite of what it's saying, since it works either way?
it does work either way, but if this wasn't a factor or didn't give us a 0, then this one wouldn't either. Yeah, and it does seem like the negative case is a lot nicer because here it is. But really, we would be looking at all this is going to go away. So is this. Well, I can leave him. He is going to be 0. Because if we did 1 minus 2i, it'd be 1 minus, here we'd still have 1 minus 2i. We'd add 0. This time, instead of doing 1 plus 2i times 1 plus 2i, we're doing 1 minus 2i times 1 minus 2i. And we could come over here and say 1 minus 2i times 1 minus 2i. We need the second one. Okay. Which would give us negative 3 minus 4i. Which would be negative 2 minus 4i. It would still give us negative 10, 0. So it just works out. And then if we did the positive case for the next one, it works out nicer just because we have less terms. It's kind of condensed already. Questions on this here? So we've kind of stated this already. If f of c is equal to 0, then x minus c is a factor of f of x. And if f minus c is a factor of f of x, then f of c is a 0. So if we do synthetic division, what we just did, and get a remainder of 0, then it's a solution. That's pretty much, if this is, then it's a solution. And if it's a solution, it means x minus c, if we solved it like we were doing kind of as a side step at the last ones, then it's going to be a factor. And if it is a factor, then it has to be a solution. If it's a factor, then it's a solution. If it's a solution, it has to be a factor. If we have one, we have to have the other. So if we were looking at this here, x minus 3, if we want to see if it's a factor of this, well, one of the first things we need to do is solve this here, get it equal to 0. Well, what minus 3 is 0? 3. So the solution for this here is 3. And a lot of times with these here, it's just flip the sign, because we would add 3 to both sides, so it's 3. Numbers across the top, we would have 1 for x to the 4th, negative 1 for x cubed, negative 11 for x squared, 11 for x, and 12. Drop the 1. 3 times 1 is 3. Negative 1 plus 3 is 2. 3 times 2 is 6. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. 11 plus negative 15 is negative 4. 3 times negative 4 is negative 12. So is 3 a 0? Yes, because it gives us a remainder of 0. So does that mean x minus 3 is a factor? Yes. And knowing these here are helpful because if we can find some factors, it's going to help us solve the polynomial function later or find it as a set of linear terms. Because what we've done is taken it from an x to the 4th as the biggest exponent, variable to biggest exponent, now to x to the 3rd. And if we have another, we can take it down to x squared, and we can keep simplifying from there. Now we can do the same thing for negative 2. Because we solve x plus 2, just minus 2 from both sides, we get this here. And go through the same process. Negative 2 times 1 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is positive 6. Negative 11 plus 6 is going to be negative 5. Negative 2 times negative 5 is positive 10. 11 plus 10 is 21. It's not looking good for this here. Negative 2 times 21 is negative 42, which gives us negative 30 as the remainder. So is negative x plus 2 a factor? No. Now, kind of a cheat way around this is, well, we could have graphed this on the graphing calculator, and if it crossed at positive 3, then that's a solution. X plus or x minus 3 is a factor. If it crossed at negative 2, then x plus 2 is a factor, because it's just working from one to the other. Because if it crosses the x-axis, it means a solution saying x is equal to 3 or x is equal to negative 2. Here, if we subtract 3 from both sides, or here we add 2, we kind of get it back to a linear factored form. And that's really it. Questions on this here? So this here is the last thing we'll look at, then we'll kind of move on to 3.6. Now it wants us to express this as a product of linear factors. That means we're going to have multiple sets of parentheses, and the x as exponent has to be 1. Now it could be a set of parentheses squared, but inside each parentheses, x has to be to the first power. So if we think about this as kind of factoring it out, we can do that there. Now they tell us for the polynomial, negative 2 is a 0. Now there's different ways we can go about doing this. One of them, and I'm going to show you this way here first, is that if this is a 0, that means we can use synthetic division. So 1 for x to the 3rd, 1 for x squared, negative 4 for x, negative 4 is our constant. Bring the 1 down. Negative 2 times 1 is negative 2. 1 plus negative 2 is negative 1. Negative 2 times negative 1 is 2. Negative 4 plus 2 is negative 2. And negative 2 times negative 2 is 4, which gives us a 0. Now the reason this is nice is we've taken it from a cubic, we decreased the degree by 1, now we have a quadratic. Now we don't have any other factors at this point, so what we do know is that we have x squared minus x minus 2 is equal to 0. Is this factorable? Yeah. Since the 2 is negative, our signs are opposite. One's going to be positive, one's going to be negative. The only factors of x squared are x and x. And the only factors of 2 are 1 and 2. We want the 1 positive and 2 negative. So we have that factored, yes? X plus 1, x minus 2 are both linear factors because the exponent attached to x is 1, so they're a line, essentially. But what did we say? Negative 2 is a 0, yes? I'm going to write this off to the side. So it's just saying that x is equal to negative 2. So x plus 2 is a factor. And that's the answer. So this is the polynomial written as a set of linear factors. Questions on this here? This method makes sense, yes? Now, I said there's another way we can do it. Is there a greatest common factor between x cubed and x squared? Well, x squared, yes? And if I factor it out, I'm left with x plus 1. Here, it works out that we have a greatest common factor of negative 4. This one here just worked out that we could factor it by grouping. Both of them have an x plus 1 in common, which leaves us with x squared minus 4. Now we can't leave it as this here because x squared minus 4 is not linear, it's quadratic. But x squared minus 4 is special. It's a difference of perfect squares. Signs are opposite. X and x would be x squared, and what times itself is 4. 2 and 2. Now, I could have also graphed this, because if I graphed it, found the zeros, where it crossed the x-axis, which would have been negative 1, 2, and negative 2, set equal to them and kind of work backwards. Could have gotten that too. Got that x is equal to negative 1, x is equal to 2, x is equal to negative 2. Add 1 to both sides. Subtract 2 from both sides, add 2. Kind of like we did previously, would have gotten us to the same answer. Does that make sense? X cubed minus 3x squared plus minus 16x plus 6. So I'm going to just graph this. Clear both of these out. X cubed minus 3x squared minus 16x. It's 3x squared minus 16x. Was it plus 6? Graph. Now they told us negative 3 is a solution, and we do see it crosses the x-axis at negative 3. However, the other two spots it crosses are not nice. They're not nice numbers, because one of them's between 0 and 1, the other's between 1, 2, 3, 4, 5, 6, and 7. They're not nice numbers. If they'd been nice, then we could have gone and done this a lot easier. Now, there's a good chance they're going to be irrational. They are going to be irrational. So this time we have to do the synthetic division first. So negative 3. 1 for x to the third, negative 3 for x squared, negative 16 for x and 6. Bring down the 1. Negative 3 times 1 is negative 3. Negative 3 plus negative 3 is negative 6. Negative 3 times negative 6 is positive 18. Negative 16 plus 18 is positive 2. Negative 3 times 2 is negative 6, and 6 plus negative 6 is 0. Now, we'll get into this later this week, but we have this quadratic here. X squared minus 6x plus 2. Now, they told us negative 3 is a solution. So if we add 3 to both sides, we know that x plus 3 is a factor. So part of our solution is going to be x plus 3 times, we're going to have 2 more of these. We're going to have 3 total. Now, according to the rational zeros theorem, if the solution is to be irrational written as a fraction, it's going to be a combination of a and c. A is 1, C is 2, and we look at it again, there are no rational solutions. So most likely this is going to be irrational or complex solutions, actually just irrational. It did cross the x-axis. So what we're going to have to do either complete the square or quadratic formula. And at this point here, it's going to be faster and easier to just use the quadratic formula than it is going to be to try to complete the square. At least in my opinion. Negative b. Well, b is negative 6. So negative 6 is 6. Plus or minus square root of negative 6 squared minus 4. A is 1, C is 2. All over 2a. Well, the value of a is 1. 2 times 1 is just 2. At this point here, I'd plug everything inside the square root into the calculator. Negative 6 squared minus 4 times 1 times 2 gives us 28. Now we can plug square root of 28 into this calculator here. 2 square root of 7. Can we divide both of the numerators by 2? Yes. And if we can divide both of them by 2, we don't have to do a whole lot of messing with the fraction. 6 divided by 2 is 3. 2 divided by 2 is 1. So we get this here. Yeah, you can just put them over there.
Okay, thank you.
You're welcome. Any questions on how we found these two here? 3 plus or minus square root of 7. So what that's telling us, just like with negative 3, that x is equal to 3 plus the square root of 7, and x is also equal to 3 minus square root of 7. So minus 3 from both sides and minus the square root of 7 from both sides. Minus x minus 3 minus the square root of 7 is a factor. Now for the other one, we will minus 3 from both sides, but this time we'll add square root of 7, telling us x minus 3 plus square root of 7 is the solution, which means it's also a factor. So this here written as a product of linear factors would be x plus 3 times x minus 3 minus the square root of 7 times x minus 3 plus the square root of 7. And that'd be it. Now the only difference between it and problems that have complex solutions is that we would have I instead of the square root of 7. So 7I instead of square root of 7. Questions on these here? Does this make sense? Yeah. It's above what we did in Algebra 2 because we never went this far. It would just been find the solutions, not go back to find the factors. Any questions on any of this here? And that's the end of those notes. Polynomial inequalities. We definitely did not do these in Algebra 2, but they're actually quite nice. Because if we're talking about an inequality, a polynomial inequality, we really, again, want to get it to equal to 0. It's either going to be greater than, less than, greater than or equal to, less than or equal to 0. And if we graph it, we're either talking about the parts of the graph that are above, need a pen, the x-axis or below it. Above or below, greater than or less than. Now in the solution set, if it's just greater than or less than, the points where it crosses the x-axis would not be included. If it's equal to 0, then they will be. Parentheses and brackets, open circle, close circle. That's all it's saying. So, like this here, x squared minus 6x plus 5, well, its solutions are 1 and 5. And if we're talking about it being just greater than 0, then it would be all the points going in these two directions. And if we're talking on a number line, it would just be the number line, open circle, going that way. Or if it's less than, then we're just talking about the points below it, just those there. Solve this inequality here. So we want to solve it, we'll graph it on a number line so we can see it. We'll also write it in interval notation. Now the first big thing I would say is get this thing equal to 0. Now we can distribute the 3x. 3x times x is 3x squared. 3x times negative 1 is negative 3x. Is greater than 10 minus 2x. Now to get this equal to 0, I'm going to add 2x to both sides. 3x squared minus x is greater than 10. Subtract 10, telling us that 3x squared minus x minus 10 is greater than 0. Now, if we were going by the pure mathematical setup for this here, we would factor this, go through finding the factors of it. And we could do that here because we're going to end up having to. And going from that there. And the reason I say that is because 3x squared is going to give us fractional solutions. So we'll have plus and minus because 10 is negative. 3x squared, well, we'll have x and x, 3 and 1. Factors of 10 are 1 and 10, 2 and 5. Most likely we're going to use the factors of 2 and 5. I'm going to say 5 and 2. And if I check this here, 3x times negative 2 is negative 6x. 5 times x is plus 5x, which does indeed give us a negative x. Now we can set both of these equal to 0. Minus 5 telling us 3x is equal to negative 5. Divide by 3, so x is equal to negative 5 thirds. Here we can add 2 to both sides and get x is equal to 2. Now, really, if we were doing this, we would set it up so that we use the inequality signs, so greater than both of these here, and work it that way. I use these as what I call key points. Negative 5/3 and 2. Now we know it's not equal to, so both of these are open. And if we didn't have access to the graphing calculator, what we would do with this here is pick points between them. So I know that 0 is between these here, 3 is between these here, and negative 10 is over here. And what I would do is plug it back into the original formula. So we started off with 3x squared minus x minus 10 is greater than 0, yes? So we can check 0. 3 times 0 squared minus 0 minus 10 is greater than 0. Well, this whole thing is 0. Is negative 10 greater than 0? No. So that means all the points between it do not work. So that's part of this. Any number between negative 5/3 and 2 are not part of the solution, because negative 5/3 and 2 are where it crosses the x-axis, so everything between those does not work. Now, x squared is our biggest exponent, yes? Which means it's a U-shaped graph. And it's opening up. So if this part's not part of the solution, it means that these two should be. And if we checked it, 3 times 3 squared minus 3 minus 10 greater than 0. Well, 3 squared is 9. Negative 3 minus 10. 3 times 9 is 27. Negative 3 minus 10 is negative 13. Is 14 greater than 0? Yeah, so that's part of our solution. So that means everything on that side of 2 works, which means anything bigger than 2 will be a solution. So if we were doing this on a number line, we'd highlight all that in. And we can do the same thing with negative 10. Negative 10 squared is 100. Negative 10 is plus 10. Those cancel. Is 300 greater than 0? Yes. So that works. So we have all this here. Questions on any of this here? Now in interval notation, we just write this as an interval. So the smallest number we have is negative infinity, comma, negative 5/3, union, 2, comma, infinity. Now the infinity and negative infinity will always have parentheses, but because this is just greater than, it's not equal to, we have parentheses there. That's also why both of these circles are open. But that's it. Questions on any of this here? Be ready for the next one. So, solve this here. Well, let's get it equal to 0 first. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Unlike last time, we're going to do this in one step. 2x squared. Negative 2x plus x is negative x. 2x squared minus x minus 21 is less than 0. questions on this here? Minus x minus 21. So we have this here. So we're talking about where it's less than 0, yes? We're talking about just the part of the graph that is below the x-axis, yes? Which would be everything between our two solution points. Now, one of the solution points, incidentally, is -3. That's kind of nice to know. Because as a factor, it would be x plus 3. So if we factored this, since the 21's negative, our signs are opposite. Factors of x squared are x and x. Then we're going to have 2 and 1, yes? But we know x is equal to -3. So one of our factors is x plus 3, yes? That means the 2 has to go over with the negative. What are the factors of 21? Or one of the factors is 3. 3 and 7. X plus 3 is 0. 2x minus 7 is 0. Here, x is -3. Surprise, surprise. Not really. We knew that was going to happen. Now the other one, we can add 7 to both sides. Divide by 2, telling us x is 7/2. Now on the number line, our two main points are going to be -3 and 7/2. Now again, it's not equal to, so both of these are going to be open. They're going to be open circles. Now, looking at the graph, what part of the graph is below the x-axis? Is it between the 2 points or going away from those 2 points? It's between them, yes? Which means for us, this is the only part of the graph that's below 0, less than 0. So it's the only part of it that works, which means...
May I have your attention, please? All the band kids and classes, please go to the library today. Thank you.
As an interval, -3, 7/2 is the solution. We could pick numbers between them to test them like we did on the last one, and that's the only one that's going to work. Because if we looked at even the graphing calculator, if we go, say, -5, it's 34, that's not less than 0. It doesn't work. However, 0, which is between our two, is negative. It is less than 0. And if we say 7, which is going to be greater than 7/2, is greater than 0, it doesn't work. Does that make sense? Okay. I know the bell is going to ring here. Let's do this one here, and then we'll pick this up probably on Wednesday. We'll see. If it ends up being we have to do all 3 days, we'll do all 3 days with how the days go. Here, we just need to get this equal to 0. So what that tells us, we have x to the 4th plus x cubed minus 8x squared minus 12x is greater than or equal to 0. Since x to the 4th is our variable with the biggest exponent, we're going to have 4 places at least that it's going to possibly cross the graph because we should have 4 solutions. One of the solutions is going to be 0. Because do we have a constant term here? Nope. So x equals 0 is going to be one of them. One of the things we can do is go to the graphing calculator, x to the fourth plus x to the third minus 8x squared minus 12x minus 8x squared minus 12x. Graph it. Okay, we do have three places it crosses, yes? And one of them, it doesn't cross, it just touches, which is really telling us that at -2, there are two solutions there. At 0, there's 1. At 3, there is 1. So -2, 0, and 3 are our three key points. -2, 0, and 3. These are our key points. Now this here is telling us that it is equal to, yes? So that means each one of these is going to be included. Because at those 3 points we are equal to 0, yes? Now it's wanting to know what? Where is this bigger than 0, yes? Now we could pick test points. So I can grab this here. I can pick test points, so let's see here, purple. Really? So I could pick -1. I could pick 1. We could pick 4, and then we could pick, say, -4. I could pick these points that are in these locations, like we did on the first one, and plug them in and check it. So I could plug -4 in and see, do we get a value greater than 0? We could do the same thing with -1, 1 and 4. The one thing is I can go over here and look at the table. Is -4 greater than 0? Yes. So that means -4 works. Then we can do the same thing with -1. -1 gets us 4. Is that greater than 0? Yes. So that works. Then we can move over to 1. Does when x is 1, do we get a y value greater than 0? No. So that means this one does not work. And lastly, we can look at 4. At 4, do we have a y value greater than 0? Yes. So that means 4 does work. So everything over here is included between these two and all the way over here. Well, wait a minute. On the graph, we're just saying everything above the x-axis, yes? Or the only spot that it's not above the x-axis, between 0 and 3, yes? Everything else is going to be included. Now, as an interval, well, since we're going completely this direction, the smallest value we can have is -infinity. -infinity all the way to -2, yes? So we also have everything between -2 and 0. So it'd actually just be -infinity to 0. Bracket, because it's included. Union, because we have to do that because between 0 and 3 is not included. Bracket 3, comma, infinity. Questions on this here? So it's not too bad. There's not a whole lot to this, especially if we have the graphing calculator. I will say that there is a slight difference, and I'll let you guys go to lunch or breakfast here. If it had just been greater than, and these points here were not included, well, it doesn't really change that much on the graph. We just have zeros at those spots. The big thing that does change is our inequality, because here we'd have to say -infinity, comma, -2, parentheses, union, -2, comma, 0, union 3, comma, infinity. We'd have to set it up so that it doesn't include those specific points. But other than that, it's the same. All right? Y'all can go on to breakfast. We'll finish this